Okay, thank you, Vikash, for giving me an opportunity to meet such a august gathering from all over the country. Good afternoon to all of you, my dear participants. Today, this is an occasion where we actually study how to do cluster analysis in SPSS. So that is the theme. So my lecture was scheduled on Monday, but then it's a Saturday afternoon. So due to some reasons, it has to be shifted today. So I think you had some idea about how to enter the data and how to work in SPSS. Given that, let us have a look at cluster analysis. And so please give me an opportunity to share my screen and take you to a presentation which actually deals with cluster analysis. So let me try this. So, can you see my screen?
Yes, sir.
Yes, sir.
Okay, thank you. So we actually start on working on this, try to understand a little bit about cluster analysis before we actually see how we can do this cluster analysis in SPSS. Let us try to understand this technique. This is a multivariate technique. Multivariate technique means there are many variables which we have to deal with, deal together. And then the method of cluster analysis basically is a technique of classification, where you actually try to divide the subjects into some groups based on certain similarities. Before going to cluster analysis, well, let me have an idea. Let me take a blank slide and give you a little bit idea about the multivariate data set and what we are planning to do. So let me take a blank screen. Okay, yeah. And then let me try to explain to you. I will take your feedback after every, say, 5 minutes. At that time, whatever questions you have, you may ask at that time, or you may also write in your chat box. In the chat box, I'll give you feedback sessions every 5 minutes. So let us start this. So what we basically have is that we have some subjects. Subjects means individuals, maybe whatever you are studying, maybe institutes, maybe organizations, maybe banks, maybe households, maybe individual members. Whatever you are studying, basically, your sampling unit. Suppose I am collecting information from a group of individuals. So I will have some serial number which are actually unique, and I have the name or some identity of some individuals. So I have here n number of individuals. So these are there, and then I collect information on different variables on them. Suppose I ask their name. Now, name is actually not so much used. You say first one is name is Amar, then Akbar, Anthony, Sanjay, okay, and so on. So I have some individuals here. Now, this name is basically to identify the individual. We don't have anything to do about the analysis. But we may have collected information about their ages. So I have information about their ages. So I have their ages. I have, say, their information about their gender. So I have like male, at the dot. So I have information about their gender. I have information about, say, their maybe their salary or income. Salary. I have some entries here. I have some values about their savings, etc. So you see what happens for every individual. Say this serial number 1 or every whatever Amar, whatever. He is giving me information on many variables. Whoever individual you pick up, you will have the information of this individual on many variables. Okay, and we initially we think that all the information is complete. That means complete means if I pick up Akbar, I can get information about all the variables from Akbar. Like I will get his age also, I'll get his gender also, I'll get his salary also, I'll get his savings also. Let us assume that all the information is complete. There are obviously cases when you might miss some information because either the information is not available or not provided, or the person is not in that stage. For example, Amar is 19 years, might not have a salary because he might be a student. So you might not have his salary, and so since you don't have his salary value, so obviously there is no point of getting the savings. So some such cases may arise. But for the time being, let us think that the data is complete in itself. Now, given this data, what we want to do is that we want to group these individuals, these n number of individuals, say into 4 groups, 5 groups, such that this is one group, this is another group, this is another group, this is another group, this is another, such that an individual is in any one of the group and only one group. For example, if I classify Amar in this group, then Amar cannot be in any other group. Now, when I complete Preet, if I put Preet in this group, then Preet will not be in any other group. And if I put Anthony in this group, so we understand that Anthony and Preet have something in similar. That's why they are, or many things in similar. They are in certain extent, they have some amount of similarity. So this is the purpose of clustering. So at the end of the study, what we'll get these individuals getting clustered into, this is say cluster 1, this is cluster 2, this is cluster 3, this is cluster 4, this is cluster 5. So I have 5 clusters. All the individuals will get divided into one and any one cluster, and all the individuals will get divided. That's for certain. It means there will be no individual you will tell that no, I cannot classify this individual. Is quite separate from all others. In case you get really someone who is separate from all others in different aspects, he or she may, or the subject may form a single a cluster with a single individual. That is also a possibility. But then we need to classify them into one or more, means in some clusters. So that is the purpose of cluster analysis. What is the use of this? You see, these use are multi-purpose depending on what you are studying. Same technique you can apply if you are working in education. You may use this technique to actually classify the students or the learners into some groups based on their similarity. You can group your customers depending on the type of things that they purchase. For example, these days multi-retail shops are quite popular. Multi-branded retail shops where like this Smart Bazaar, etc., where people go, they purchase different types of product. Now you may find that the individual they have products. Some individual might be interested in purchasing health-related products. Some individual might be interested in purchasing grocery-related items. Some individuals might be interested using fashion-related items. So you can, at the end of this data, because you'll see that whenever you go to some multi-branded retail outlet, when you come out of the shop at the time of billing, they ask you your phone number. Actually, phone number is a unique ID. They don't ask your name. Your name is not interested, because in a database, when you do the analysis, the least important thing is probably the name, which is never used in analysis. But obviously, name is, in another way, name is not less important, because if I want to identify, if I want to go back to my database, if I want to scrutinize the database, I need to know the name of the individual, the other details. So that's the reason why name is not actually dropped from the database. But if you look at the analysis of your database, the name seems to be least important. Now here, other information is important, like mobile number. Why they ask about mobile number? Because mobile number is generally unique. One individual has, means one mobile number is connected to an individual. So if they take, we have multiple SIMs these days and we have multiple numbers, but these multiple numbers also connects to one single individual. So that's why they ask, because they want to have a particular variable which is unique in itself. Name is not unique. There are many people with the same name. So, and then name, sometimes spelling matters. If you ask my name, then you will definitely make a spelling mistake when you type it out. Or some other name. There are different ways of writing the same name, which is pronounced in the same way. So this is the thing that happens in a database, and this is roughly the purpose of cluster analysis. Now you can ask some questions if you have. or we can proceed. Okay, any questions? Anything in the chat box? Someone may read out because I am in my PowerPoint screen.
Yes, sir. Yes, sir. Anyone have any questions? Okay, sir.
No, sir.
Okay, then let me go to the next slide. Well, so what we have discussed, let me take a brief of that. So multivariate data analysis, we are interested in more variables. More than 3 variables comes under multivariate. 1 variable is univariate, 2 variables are bivariate, and 3 variables are trivariate. More than 3 is multivariate. So I have a large number of variables collected from a group of individuals which we term as subjects. Here individuals does not necessarily mean human beings. These individuals are actually sampling units of whatever you are studying. If you are studying in household, then your household, each household is a multivariate. Each household is a subject. If you are studying furniture, then each unit of furniture is a sampling unit and or a subject. If you are studying animals, so that way it goes on. And then what is the purpose of this? We want to find some similarity between the subjects so that we don't need to. Let me take a simple example to explain this. I take you back to the time when we initially had the mobile, say in the early 2000, later part of the last millennium. When we started to have mobile phone, you must be having, those who are little bit senior might remember that your first phone definitely was Nokia 3110. And that was a model which was quite popular when initially the mobile phone was mobile phone came. It's a famous model number, Nokia 3110. Now that keypad type phone. Okay. Now that was the time when actually these things were becoming popular, like mobile and mobile technology. Now a time come when and then what you can do in mobile, we can talk, we can carry it from one place to another, and we can send SMS sometimes. So that was the basic purpose of mobile phone. Okay, fine. Then one day I got a call from, I got a message in my mobile phone, an SMS. So in that SMS it was written like मुझसे बातें करे, मैं अकेली हूँ, and then there was a phone number given. I got scared because the number did not come from any mobile number. It came from some coded number, and then there also, which was alphanumeric, that coded number. And then someone asking me मुझसे बातें करे, and probably gave the name also, myself Sheila, मुझसे बातें करे, मैं अकेली हूँ, and then gave a phone number. I got scared that who is actually sending this. So then I asked one friend. He used to work in a Tata Telephones those days. Tata had a telephone company. I think it is not there nowadays. So I asked him that so I got some message like this. Then he told that no, you may ignore it. I thought I got very scared. Who has sent me such a message? He told that it is then I told them, then why this individual is sending me message? No, it's a company. They have some tie-up with the telecom company. So when you talk to them, you will be billed, and a part of the bill will go to that telephone company as well. A part of the bill will go to the particular people who are running this service or whatever. I told them, okay. Then he, in order to, but even then I was not very convinced. And then he, in order to make me convinced, he told me that ऐसा नहीं है कि तुम्हारे और मेरे पास ही ये आया है. It even came to my father also. This same message came to my father, who is around say 80 years old. Then I found that subsequently when my father also purchased mobile, I found that such message comes to his mobile also. So same thing only, 70 plus what he will do to talk to someone. Okay. Now this, if you look at this situation, means they are randomly sending SMS to all the subscribers. Now suppose to a lady this message goes that मुझसे बातें करे मैं अकेली हूँ, मैं शीला, मुझसे बातें करे मैं अकेली हूँ. Okay. Why will another lady call Sheila? Obviously not. So there is no chance of a lady calling Sheila. Okay. Then this message they are sending to my father and that of people of my father's age or say 50 plus or 60 plus age. Now, highly unlikely that such people will call back and talk to Sheila or whoever, whatever. So they are also not participating in. But for this particular SMS, someone is paying, either that particular telecom company or that particular company which is running this type of services. Sorry. So then where do we stand? We stand that they are actually spending money on a large number of customers or large number of subscribers who will never become their customers or neither their potential customers. That means there is no market segmentation. Here comes a very important thing, that you have to reach out those people who has a chance of purchasing your product, not to people who will never in the in a very far away dream also think of purchasing a product. No point. That means there is no particular cluster analysis being done. Clustering is being not done. Customer segmentation is becoming a very important aspect of marketing management, that you identify your customers. So for doing that type of segmentation, if we have a database of things purchased by different individuals, say from a multi-branded retail outlet like Smart Bazaar, etc., then using that data set, I can identify that for a particular product, what may be my potential customer. So in this way, there are different ways in which, based on level of performance in the different events, also you can categorize a group of athletes as top, middle, low performing, like that, based on different. When there are more than one sports or more than more than three at least type of physical activity. So here comes the importance of cluster analysis. Before going to SPSS and C, cluster analysis, let me just give you an idea about, because little bit of mathematics we need to know that how do cluster analysis basically work. Obviously, this is a computer program which is written and placed in SPSS, and when we run the program based on the database, it finds out that who are the nearest neighbors. Nearest neighbors are put into one group, and as the distance between the neighbors increases, they are actually grouped in a different group with some other people who are similar or some other subjects who are similar to the second category. So there is a measure called as the distance measure. For example, it's very simple. Suppose you have a relative in your town, same town you have another relative, and then if I take that, what is the distance between you and your relative, you will generally mean that what is the physical distance, means what is the means in terms of kilometers or in terms of meters, what is, or kilometers, yeah, what is the distance? Maybe 3 kilometers. My uncle stays 3 kilometers away from. Sometimes distance is converted into time. Sometimes we tell like this, my uncle's house is 10 minutes away from me. 10 minutes away. Now this is a very vague type of thing. 10 minutes means what? 10 minutes walking, 10 minutes in bicycle, 10 minutes in motorbike, 10 minutes in car, 10 minutes in a flight, whatever. What is that? And what was the road condition? Many other things are there, but then distance is quite simple. I mean, that means we are actually expressing the distance between me and my uncle with the help of a physical distance separating us. So this is univariate. But if you think about my variate, means a multivariate setup, that how far my uncle is from me, not only in terms of distance, say in terms of distance. Now, accidentally, if my uncle is of my age group nearby, for example, my maternal uncle, the youngest one, is only 6 years or 7 years elder than me. So we are almost enjoying the same same group. Anyway, so means now bring in many other, not only physical distance, but many other factors, like maybe one is the physical distance, one is the age difference between us, one is our family sizes, one may be our income, etc. So when there are many variables coming into place, then the distance is actually measured on the different variables, and then we actually square it up. For example, if you look at this formula, just give you I'm not going to bore you much with the formula. Say, look, this is a distance between two individuals, A and B. I call it D. This is say age, my maternal uncle's age, whole thing square. Plus, this is my distance between our houses, this When you subtract, you get the distance between our houses, say 3 kilometers whole square. Like this may be our income, my income, his income, whole square, like this. This is called as Euclidean distance. This is called as Euclidean distance. Based on this Euclidean distance, my uncle and me, we will be in the same cluster or in the same group if the distance between us is less. But if the distance between us is more, my uncle will go and join some other group where he will get some other people who are in his proximity, and I will be in another cluster or group, and I will have people of my proximity. But since my uncle is far away from me in terms of age, in terms of income, in terms of distance, etc., so he will be distantly located. So this is the basic, this is the only mathematics behind cluster analysis. Okay. Now we are going to data analysis. Can we have some questions now in case you have?
Yes, participants, anyone want to ask a question?
No, sir. Please continue.
Okay.
Hello, sir.
Yeah.
Sir, I think since I am from the social science background,
Yes.
in the previous slide, it is little bit difficult for me to understand the different, the formulas and things. If it will be more easier for me if you could give the example and then relate it with the research. So it.
The first thing is that say means you see, you must be having a car or a motorcycle. Do you have anything like vehicle?
Yes, sir. Yes, sir.
Then what happens when you ride it? You don't need to know the engineering. Engineering kya hai? Are you interested to know the engineering? You know how to drive. You can drive it from one place to another, and that helps you to move faster. That's fine. Little bit okay. If you see this, then petrol is going to get over soon. You understand little bit of these technical things, which is very necessary for you. But the more detailed technical things, some people have means they with experience they learn these things. But then otherwise there are so many engineers doing it. Means engineer means mechanic whom you take, they will mend it. So actually the basic engineering behind the technique is not very necessary for you since you are from social science. So it is not very necessary for you. But the thing is that many people ask the question, ye kaisa ho gaya? How it happened? What is the logic? Because all techniques must have a logic behind it. That okay, you are speaking about distance. So how you are measuring it? I can give you an example, it doesn't matter. But the thing is that how much necessary it is for you. That is one question. Even then, let me tell you, say, you are from which discipline, brother?
Sir, I am some political science and international relations.
Okay, political science and international relations. Okay, let me take up this. Suppose you go to a particular village. Okay, you go to a particular village. And then in this village, you are interested to know that who are the individuals who are similar in some respect. Because so you take some individuals. So these individuals you take there, say, just 1 minute, let me. Okay, this is a particular village. In this village, there are many individuals. Now, what happens? You take some criteria. Say, first criteria you have taken is say their age. Then you have taken their income. Then you have taken their caste from which they belong, and so on and so forth. You have collected information from that. You want to understand that which party they must be following, etc. But then you don't pose a direct question that aap kis party ke follower, because you know that people are actually means these may not tell directly about the information the party they follow. But then you want to find out some similarity in terms of their socio-economic background. So collect some information about the socio-economic background. What may be the socio-economic background and demography also, like their age, gender. These are demographic information. The caste from which they belong. So this is some social information. Then whether they are employed or not. What is their household income? Whether they live in a pakka house. Whether they have some landed property, etc. So these are some variables on which you are taking some information. And once you take this information, then at the end of the day, you get a big database. Database say you have collected information from 60 people. So you have information about 60 people, say 1, 2, 3. Okay, like this you have 60 people. And then we have, this is the serial number. And then you have the information about their age, their caste, their income, then whether they have land or not, etc., etc. And then huge database you have. Now, based on this database, you want to divide them into 3 clusters, 3 or 4 clusters, such that in the clusters that will be formed, it will be populated with some similar people from out of these 60 people. Not necessarily the cluster size will be 15 each. Someone may have 10, some may have 20, and even the Jamindar, who is actually so much different from all the other people, might form an individual cluster with only himself, no other people in and around him in his cluster. Now, what happens in this case is that when you have this cluster, and when you look at the individuals of this cluster, say cluster number 1, you may find that they are mostly women coming from a particular, senior women coming from a particular caste. That means these are senior women, these are loaded with senior women. That means there will be some similarity among them. They are senior women, say 50 plus women. They are unemployed. They are dependent on someone else for their daily bread and butter. They belong to a particular caste, and so there is some similarity among them. These are the people who might be young men who are working in outside the village, going outside the village to earn their livelihood. Occasionally they come back to the village, but generally they stay outside the village. This might be your cluster 2. So this way what happens, when you do this cluster analysis, based on the many variables information that you have collected, they will try to reduce the entire data set and put individuals in some groups which are such that each group, members within each group are similar amongst themselves, and member between 2 groups will be different from each other. For example, this individual will be different from this individual in different aspects in most of the variables. Some 1 or 2 variable might be similar, but in general they will have a different view. So how to measure similarity and difference? That is called as an Euclidean distance, which formula I have shown. If you think that the formula is difficult, a formula to bouncer gaya, मुझे कुछ समझ में नहीं आया formula के बारे में, no need to know, because when you drive your motorcycle or your car, you don't need to know the entire engineering. What is the entire engineering behind that? But what you need to know, that what is the purpose of cluster analysis. Number 1, you need to know what is the purpose of cluster analysis.
Sir, I got your point. Thank you so much, sir.
Okay, number 2, what you need to know, that how to do cluster analysis or whatever technique you study for performing this in a particular software. Say this is a workshop on SPSS, so we'll see how to do this in SPSS. Number 3, what you need to know, that after SPSS do the analysis, how to do the reporting of that particular result which you have got. If you have the information about all these 3 things, you are done with a statistical technique. और मतलब काम चलाओ तुम्हारे पास आ गया है, तुम्हारा पर्पस मालूम है, you got the purpose, you can understand how to do this in SPSS, and then on getting the result, you know that how to interpret the result. This is fine. Now you can go back to your own domain and then do. That much is required. If you want to know more, there is no end of learning. But okay. So is it fine? Shall I proceed?
Yes, sir.
Yes, sir.
Okay, now let us look at this. I have a data set. In the data set, I have 5 variables. One variable is the name of some students, small children are there. Then I have information about their age in their last birthday. And I have gave them in their class. I gave them 10 questions and I asked them some the answers, and this is the number of correct answers that they can answer. And then I had an study on their IQ level, which is a binary variable categorized by if they are below average, IQ level below average, then 0, above average, then 1. And then I had a storytelling ability. There what I did, I told them a story, and then I asked them that please tell me the story that I told you just now. You must have understood the story. Now you tell me what you understood about the story. So they actually are telling me the story back to me. And if they could tell the story nicely, almost approximately, small children. So if they can tell the story almost approximately, I am giving them mark 1. Otherwise, I am giving them mark 0. So these are the variables here. So what is the interesting variable? Name. As you know, name is not used for analysis. Age. This is the age at LBD, means last birthday. So this will be an integral, 4 years, 3 years, 5 years, 6 years, like that. Correct answer, number of correct answers out of 10. IQ level means below average, then 0, above average, then 1. And storytelling ability, whether they are able to tell the story. Now here we use two types of cluster analysis are there. There are several types of cluster analysis. We'll do two types of cluster analysis because these two types are available in SPSS. One is the hierarchical cluster analysis and another is K-mean cluster analysis. So this is hierarchical cluster analysis. Now when we use hierarchical cluster analysis, we use hierarchical cluster analysis when my data set are either binary or they are some integer values. For example, age last birthday, so that will not be fractional. Okay, that will not be fractional. Age at last birthday will not be fractional. Then we have this correct answer may be 1, 2, 3, 4 out of 10. So maximum 10, minimum 0. So this will be a numerical quantity. So out of 10. So this is a numerical quantity, means integer, not a real number. That means we will not have a decimal. This is binary, so 0 and 1, and this is also 0 and 1. So these both are called as binary. So when we use hierarchical cluster, when the data is binary or count means number, integers, count data. How many children? 5, 6. How many mangoes? 3, 7, like that. So this type of data, when these type of data are there, that is non-fractional type of data, then we use hierarchical cluster analysis. Purpose is same, to divide your subjects into some groups called as clusters. So this is what is written. Now let us look at this SPSS data set and try to understand that how this is working. This is an SPSS data. I presume that by this time all of you know how to do this SPSS analysis. Means at least you have the experience of encountering the data set. So these are the name of 20. If you want, later on I'll pass on the PowerPoint and the data set to the organizer so that you can practice this in the same lines as I am explaining. Because you see, practice makes a man perfect, and so far as software is concerned, it is even more true. Practice makes a man perfect. Woman also. So everyone needs to practice. Okay, fine. So these are the name of the individuals, as you can see here. Okay, so these are the name of the individuals. This is their ages. Last birthday 4 years, 6 years, 7 years, 8 years. So small children. Okay, fine. Correct answer. Someone is giving 6, someone is 5, 8. Also we have some 7, and some people are giving 9 correct answers. And then IQ level 1 means above average IQ. And then intelligent quotient, there is another way of measuring intelligent quotient. Those who are from education, they know it. Anyways, so, and then this is 0 means below average intelligence quotient, IQ below average. Storytelling ability, these are the people who could not tell the story properly to me, and these are the individuals who can tell the story. They are arranged in an order so that other orders obviously will get disturbed. So names are also not alphabetical, because they are actually arranged in the order of this. Doesn't matter. My purpose is to do the classification of this, which we call as cluster. There are other methods of classification also. Cluster is quite simple. Mathematical technique used is mostly Euclidean distance, which we have seen. Someone telling that it is very difficult. Okay, never mind. If it is difficult, just remember the name. Euclidean distance. Same individual who actually, you must be knowing the Greek scientist Euclidean. So we come to analyze, we go to classify. So this is the flow. We do analyze here, we click on analyze, and then we go to classify, and then we come here. You see the k-mean clustering is waiting here to be done later on, but now we are doing hierarchical cluster. So this is the flow: analyze, classify, hierarchical cluster. Once we press enter, we get a small form over your database which looks like this. Now you have some options here, like you can see these are all the name of the variables. With your little bit or more experience with the SPSS, I don't know which one is true. You must have noticed that whenever you want to do some analysis, name of all the variables comes in a box in the left hand side. And from left hand side to right hand side, you take those variables which are of interest to you. So what happens here, the variables based on which I will do my clustering is age at last birthday, correct answers out of 10, IQ measured below, above, etc., the capacity of retelling the story, etc. These are my variables. So all the variables I will bring here. And a name, these I will bring here because I have to identify that which individual is in which cluster. So this is, you see, level, not level, but it's level. Level means just a tag. So level cases by name. So I'll bring name here, other variables I'll take here. So I bring name here, as you can see here, and other variables I am taking here. And then what I do is that I come here. What I want to do, cluster cases or variables. Cases means those individual students, and variables means those variables like IQ, storytelling ability, etc. Obviously, I want to cluster my students so that I can understand that who are the people who are similar, not necessarily better or poor, like not like that, but similar. Okay, so I go with cases. So I click on check on cases, then I go to here, I come here, statistics, and statistics I click here, then they give a proximity matrix. This is not so important. Proximity matrix is important, so I click on proximity matrix and make it active. Proximity matrix will give a full matrix of all the individuals. These will nothing but give a measurement of the distance between each individual with each other individual. So how much far you are from yourself? Obviously 0, because you are having the same age as that you. In 0 distance, you are having the same income as that of you. So your distance from you will be 0. So other than that, your distance from some other individual will be 0 only if all the values are same. We'll see in our database, some people, they have all similar values. Anyways, so okay, then we come back to continue, click on continue and come back here. I repeat the steps once again. So we started this analyze, classify, hierarchical cluster. We come here, we take all the second to this fourth variable, second, third, fourth, fifth variable, we bring under variables, and the first one, that is name, we bring under levels. After doing this, we come to, this is the cluster, we want to cluster cases, so cases, and then we go to statistics. In statistics, if you want, you may activate proximity matrix. If you don't want, proximity matrix jane do. Actually, you are interested in the cluster, you might not be interested in the proximity matrix. So in that case, you may avoid proximity matrix because that is a very big table and very difficult to handle in a research paper. You are writing a research paper, then putting a proximity matrix, doing cluster analysis, putting a proximity matrix will not look nice, because it's, if your subject is more, it will be very huge, large, because it will give you the distance of each individual with each individual. Anyway, so minimum is that you just go to do this and then click OK, minimum. Okay, fine. And then there you see plots. Okay, plots I already have ticked here, so doesn't matter, but you can check plots, and then you see there is one dendrogram. Dendrogram is a graph. I repeat, dendrogram is a graph which helps us to make the cluster or helps us in the formation of cluster. So dendrogram has to be activated. Acha, dendrogram is related to hierarchical cluster only, not with respect to k-mean clustering. Okay, so hierarchical clustering, you should do the dendrogram. Okay, and then you go to continue. Okay, and then method, there are many methods, so you may keep the default method. Okay. And then distance, there are many measures of distance. You may keep equality and distance, that is the default method. So you may keep equality and distance. I am just showing you what are the options. नहीं तो कोई बोलेगा कि सर स्टैटिस्टिक्स के अंदर क्या है दिखाया नहीं, प्लॉट के अंदर क्या है दिखाया नहीं, मेथड में क्या है दिखाया नहीं. तो दैट्स व्हाई आई एम शोइंग यू. बट द थिंग इज दैट इफ यू वांट टू डू क्लस्टर एनालिसिस, जैसे किसी बच्चे ने बताया कि आई एम ए सोशल वर्क सोशल साइंस स्टूडेंट, आई डोंट वांट टू नो ऑल द डिटेल्स, मैथमेटिकल डिटेल्स बिहाइंड दिस, then what you do, let me tell you very frankly. First you think, what you do is that you take the variables which has data here. Okay, fine. If you think that some data is not important at all, you may not bring it also. It is your call. And here you take some variable which consists of something with the help of which you can identify the subject. Maybe household number if it is households. Maybe name if this is individual. Or maybe some codes if this is something else like animals, etc. Okay, fine. And then you go to this, you check out this. In case this is not checked, you just check in this. Cases, by default it will be cases only. Variable is a very special case. Some individual may need some variables, but generally I have never used in my life variables. कभी जरूरत नहीं पड़ा, ऐसा नहीं कि मुझे नहीं आता है, बस यह वेरिएबल चेक कर देना है, nothing else. But generally this is done for identifying or segregating the cases only. And then you click on OK. So by means minimum, that is the requirement. Other things, statistics, you have seen there are different ways of measuring. Plots, dendrogram only, just if you want horizontal or vertical. Vertical is good enough, so that will be drawn by default. Method means how to measure the distance, equality and distance, square distance, cosine distance. कुछ तो मुझको भी मालूम नहीं है कैसे मेजर होता है, बट कंप्यूटर कर देता है. तो go with equality and distance. Okay, fine. No need to touch this and enter into that form. Just leave it. Just click on OK. So as you click on OK, first you get the proximity matrix. You see, try to understand this proximity matrix. This is 0. This is the distance between Oscar and Oscar. Obviously, it has to be 0. And then the next one you see also 0, because Oscar and Susie, basically they have the same numbers. If you go to your database, let me take you back. Oscar and Susie, let us check out. Oscar and Susie, you see here, Oscar is 4, Susie is 4. Oscar is 6, Susie is 6. Oscar is 1, Susie is 1. Oscar is 0, Susie is 0. So they have the same values, and that's the reason why when you go to the proximity matrix, we get that, okay, well, they have the same distance, and sorry, this one 0. But you see Oscar and Kimberley 1. Oscar is little bit far away from Kimberley. Oscar and Lousy 5, quite a big difference. And Lousy and Ronald 5. Okay, is Lousy and Ronald very close to each other? Let me see. Where is Lousy and Ronald? So this is Lousy's column, and where is Ronald column? Yes, you see Lousy and Ronald, they have the same data, and so the difference between Lousy and Ronald is 0. So this way you can find out some interesting things like Daisy and who is this? Gertrude and Daisy, they have large distance between them, 11. Okay, this is 14. John and Oscar, 19, 27. Jan and Oscar, very high distance, very means huge distance between them. So they will never be in the same cluster, obviously not. So this is actually based on this distance only clustering will be done. Next, we get the dendrogram. Now this is important. Based on this, we can do the clustering. Iska aise, otherwise from this graph itself we can make the cluster. Okay. Now how to do these clusters? How many clusters I want? One cluster, obviously in one cluster doesn't have any meaning. All people will be in the one cluster. So not interested. At least 2 clusters. I want to divide my data set into 2 clusters so that people with similar characteristics will be in one cluster and this similar characteristics. Okay, I want 2 clusters, fine. So how to do this? You see this building, okay, topmost building, which one? This one. How many walls it has? 2 walls. One is this wall, another in this wall. Under this wall, who are the people? Under this wall, Oscar is here, Susie is here, Kimberley is here, Cuny is here, Thomas is there, Gertrude is there, Beatrice is there, Laus is there, Ronald is there, Charlie is there. And under this, who is there? Is Fred, Peter, John, Daisy, Ethel, Angus, Morris, Harry, Noel, and Ian. That means these people will form one cluster and these people will form another cluster. This actually, this graph is obtained by SPSS using the Euclidean distance. Name of the graph is called as dendrogram. Is it clear? This what? This purpose. How to interpret this graph? Okay, I have created an animation also. For example, two clusters, you see, this is how this divides. The topmost building, two walls, this is how this division is done. This I have done an animation to explain. Now, suppose you want three clusters. Well, let me go back to this. Let me take out all this marking that I made. Okay, now I want three clusters. Try to understand this. After I explain, if you have some questions, you can ask me. Okay, now I want to make three clusters because this is your call actually, researcher calls. How many clusters you want? You may have as many as say, as many number of individuals. So 20 individuals, 20 clusters you can. But that does not, neither one cluster has any meaning, nor 20 clusters has any meaning. Generally 3-4 clusters is reasonable. Okay, suppose I want to make three clusters. Now, first is this and then this. Okay, two walls, you know what to do. After that, you see next, which is the tallest building. Next, out of this building is the tallest. Second tallest, who is the second tallest building? This is the second tallest building. Okay, this wall and this wall. Below the people below this wall in one cluster, for example, 9, 10, 7, 8, 6, 5, 4, 5, 6. They are in one cluster. And who are in this cluster? 1, 2, 3, they are in another cluster. This is the second cluster. Who are the people in the other cluster? These clusters remain unchanged. This. And then if you want their names, you can find their names from there. So Oscar, Suzy, Kimberley, they are actually, their age is also less and IQ is more than 1. So basically they are coming under the same cluster. So this is how you get three clusters. Is this point clear? If you tell, I will repeat once again at how to make the clusters.
Yes, sir, it's clear.
Okay, thank you. Now, suppose you want to have 4 clusters. No, I want 4 clusters. Okay, then what is the process? Okay, let us see what is the process for getting 4 clusters. Let me delete this. Now here you see this is the tallest building. These 2 walls I have already used. Second tallest is this one. These 2 walls I already used. After this, which is the next tallest building? After this one, this is the first. This is the second tallest. Which is the third most tallest building? Obviously this one. Now what are the 2 walls? This is one wall. This is another wall. Now you see this wall, this wall, this wall, and this wall. Who are below this wall? That from 9 to this. So this is one cluster. This side one cluster. That means this is not disturbed. Here we have a new entry here. You see under this wall, who is the individual? Only one individual, 20. And under this, who are the people? 18, 19, 16, 12, 13, 14, all this. That means we have got 4 clusters now. In the first cluster, if you consider these as the first one, that is 9, 10, 7, 8, 4, 5, 6. So there are 7 people in this cluster. This cluster is having 3 people. This is a cluster containing only one individual who is young, which is so different that in the third, fourth clustering, he completely becomes a single individual with a cluster. And then others are 1, 2, 3, 4, 5, 6, 7, 8, 9. So they are similar in some respect. So this is 9, 1, 3, 7. So you see 9 plus 1 is 10 and then 3 is 13 plus 7. that is 20. So all these 20 individuals are getting divided into some clusters. So this is how we can make cluster using hierarchical cluster analysis. Okay, so this is the animation. If you want to see, this is the animation. So now after that you can prepare the report. In the report, what are the things you are to write? You are to write that for the cluster analysis, what variables you have used. That I have used 4 variables for clustering 20 individuals into 4 clusters, and these 20 individuals belong to such and such village, etc. Information from them were collected on their storytelling ability, and then their age, their IQ, whether it is below average, above average, and this how many correct answers they gave. So these 4 variables are either numerical, or means this count data, or binary data. That means they are all integers. Accordingly, we use hierarchical clustering. On doing the hierarchical clustering, we found that Oscar, Susie, and Kimberley falls in the first cluster. Queenie, Thomas, Gertrude, Beatrice, Lousy, Ronald, Charlie falls in the second cluster. Peter, Fred, John, Daisy, Ethel, Angus, Morris, Harry, and Noel in the third cluster. And Ian individually forms the cluster. And so these are the 4 clusters into which my population is, or my sample is divided. Next we go to K-mean clustering. In K-mean clustering also same purpose, that we are to make groups or clusters where individual groups are homogeneous and then heterogeneous. Those who have read your research methodology paper, you have found that in research methodology paper there is a chapter called sampling. In that sampling chapter, there is a type of sampling which is called a stratified sampling. If you remember, the teacher must have told you, or you must have read in the book, that based on some similarity, or based on similarity, my sample is divided into some strata where individuals belonging within each strata is similar to the individual belonging from the other strata. And then we randomly select sample from each of the strata, so that my sample gets a representation from all the strata, making my sample a representative of the population. So this is what generally you have studied in case of your research methodology paper in stratification. But there actually they have given an example also. You will find that the example will tell that, okay, suppose you know the income of a group of individuals. So some people are rich, some people are lower middle class, some people are middle class, and etc. etc. And based on that, we actually make a division of the individuals like this. But the problem arises when you have many such these people, many such variables on which you need to do the clustering. That is the problem. So in such a case, actually you have to perform this this type of K-mean clustering. So that's why K-mean clustering becomes very very handy, because it can deal with count data, it can deal with binary data, as well as it can deal with integer, means real numbers, like say income, savings, data in percentage, etc. Any type of data it can deal with. So that is the importance of clustering, K-mean clustering. Another important thing is that in K-mean clustering, how many clusters you want, that you have to tell beforehand. In hierarchical clustering, as an output, you get the dendrogram, and from the dendrogram, it is up to you. 2 cluster, 3 cluster, 4 cluster, 5 cluster. You choose from the graph. After seeing the graph, you may take a decision. But in that's in hierarchical clustering. But in K-mean clustering, when you do the clustering, at that time itself, you have to say the number of clusters. That I want to have 3 clusters, and then 3 cluster may not give you a satisfactory result. You may want 4 clusters, 5 clusters. You may change it later on, but declaration should be at the beginning of the program. So obviously the data is continuous type, and same data I am using, but little bit change is there. For example, name to same name, age. Instead of taking as age at last birthday, I am taking age. That means it can be fractional, like 4.3, 7.2, like that it can be. Memory span, a score representing short-term memory span of the respondent. It's a psychological test which gives you the memory span. Means our short-term memory is controlled by the frontal lobe. Frontal lobe. For example, you must have seen that movie, Gajni. In the Gajni, actually, that there was a problem of the hero that he used to forget. Short-term memory failure was there. But the short-term memory is controlled by a frontal lobe of the brain. But in the movie, they showed that Amir Khan was hit in the back of his head. But actually, back of the head, hitting at the back of the head may create other problems, but not short-term memory failure. Short-term memory is controlled by the frontal lobe of the brain. So मारना चाहिए था सर में from the front side. तो मूवी में दिखाया वो एक्चुअली उसने तो किसी इंग्लिश मूवी को कॉपी किया था तो उधर में शायद बैक में मारा था तो वो भी बेचारा बैक में ही मार दिया. But then it should be hit on the front side because it's the frontal lobe. Anyways, so memory span is a score. I ask you some questions based on your short-term memory, and then based on that I give you a score. So that is memory span. And then IQ, here the actual value of the IQ. IQ means average normal individual has an IQ of 100. If you have IQ more than 100, that means you are becoming intelligent. Less than 100 means you are an idiot. Means if you go sufficiently beyond 100, like 80. Okay. There is another thing which is called as moron. So moron means it is idiot. Means more idiot than an idiot. Uska buddhi aur kam. So moron has less IQ than an idiot. And the reading ability score of the respondent. This is also marked. So look at this. Oh, this is the data set which we have. If you look at this data set, you may see that if you look at this data set, you can see that these are the individuals. These are their ages, which is fractional also, not like the previous one. So memory span, this is a score which is also coming fractional. And then we have IQ, which is somewhere plus minus from 100, because 100 is average IQ. So these are the individuals who are having below average IQ. But we are not speaking about below average, above average. We are just getting the IQ values. And reading ability of the children, we have, instead of storytelling ability, this time reading ability. I have given them a textbook and told them to read. So some of them are able to read, some of them are not able to read. So this is, or some of them are able to read little bit, so 5.6. Some of them could read very well, so 7.3. So these are some scores or marks. So you look at the data set. The data set is totally, it's like fractional. Okay. And so we can use K-mean clustering analysis. Okay, we come to analyze, we come to classify. Last time we were working on hierarchical cluster. This time we are working on K-mean cluster. So we click on K-mean cluster and we once again get a similar type of form. And as I have told earlier, all the name of the variables appearing in the left side. From left side, we need to bring to the right side those variables which we will use in computation. And obviously the variables are age, short-term memory, IQ, and reading ability. So these we select one by one and we bring them. And level cases by we bring them. And then one option is there, classify only, iterate and classify. That means every time they will classify and then redo it and redo it and redo it and then reach to the result. This is generally a little bit more accurate than classify only. But anyways, we go on with this classify only. Number of clusters, this one we have to input here. I have put 4, you can change it to 3. You can make it 2 also, you can make it 5. So that is the thing. And then we go to options, initial cluster, center, cluster information. This you have to check. This you have to check because this will give you that who is going to which cluster. This you have to check. So whenever you do K-mean clustering, whether you do other things, one thing is that you have to put some value here. That is, you have to do it. Classify only. This is a selection by default. So no need to change it. And then you go to options. This you have to do options and then this one, cluster information. This will be selected by default, ticked by default, but you check in this and then you go to continue. Come back here and then you click on OK. Once you click on OK, you find this is what they are giving. So you see who are these people. Here is the cluster number. It is not given separately, serially in terms of cluster, but it is giving the same thing serially in terms of the name. Like Oscar, Susie, 1, John 1, Fred, Peter 1. Then we have Harry, Daisy 2, Noel 2, Jan 2. Then you have lousy Ronald, Beatrice, Queenie Thomas, gratitude 4, and then Ethel 3. So Ethel is with Charlie and Kimberly. So you get this. These are the distance between the clusters. So, well, we have this one also, distance between the clusters. This is not so important, but you can find it out that cluster 1, this is the distance between cluster 1 and cluster 2, cluster 1 and cluster 3, cluster 1 and cluster 11. If you look at this, you will find that this is cluster 1. Cluster 1 is closer to cluster 3 than cluster 2 and cluster 4. And cluster 2 is closer to cluster 4. So you can understand that there is some similarity between cluster 2 and cluster 4 and some similarity between cluster 1 and cluster 3. In case you are interested in the result, that okay, cluster to ban gaya, ab cluster kaun kiske paas hai, if you by chance you are interested, then this table gives you some information. This table tells you how many members in different clusters, but I think more than this table, the previous table, that is this one, is more important. Now, based on this, you better prepare a report, how to report the cluster result of cluster analysis. In order to classify the children into different clusters based on 4 variables, age, short-term memory span, IQ, and their reading ability, cluster analysis was performed. Since all the variables were of continuous time data, so K-mean clustering was used to identify the subject into 4 clusters. This is your call, you see. But whether to use hierarchical mean clustering or K-mean clustering, that is not your call. That is on the type of the data. If there is a mix that some numbers are binary, some are counted, some are continuous, go with K-mean clustering. If all the entire data set is continuous type of data, that is fractional type of data, go with K-mean clustering. If all the data are either binary or count data, then you go back to hierarchical clustering. So that is the data requirement and data constraints. Okay. Now this is the cluster number 1. This based on the data that SPSS gave, I have prepared this report. That in this there are 5 children and they are this. In this there are 5 children. Once again, these are the names. Here we have 3. These are the names, and here we have 7. These are the names. You can divide, say, if you want to classify the Indian states based on different demographic parameters or based on different types of socio-economic parameters. Say you have for a particular year, not all several years, but for a particular year, you have data related to, say, per capita income, infant mortality rate, maternal mortality, then say number of doctors per 1,000 population, number of institutional deliveries, number of schools per 1,000 children, etc., etc. You have many information on many variables across all the Indian states for a particular time period. Then you can use cluster analysis and see, divide it into some 5-6 clusters, and then you can identify the top states also. So this is one application of cluster analysis. So other details cluster analysis can be placed in the appendix of your result. Means whenever you do this cluster analysis, what is important is this particular information. That what cluster analysis you use, why you use that cluster analysis, how many number of clusters you decided, who are the individuals or the subjects in which clusters who are similar. And we understand that, for example, here we understand Oscar and Susie, they are similar. For example, if I classify the states and Goa and Chandigarh comes in first cluster, I understand that Goa and Chandigarh has some similarity with each other. So like this. Okay, then this is the what way. Other results like proximity metrics or say proximity of the clusters, this type of information, if at all is required, you can put it in the appendix of your study. Obviously, you mentioned that which software you have used for doing this. So this is how, thank you. So this is how cluster analysis can be done in SPSS, how to do and how to interpret the result. If I can send through WhatsApp the data set, assuming that all of you have SPSS, and then obviously the PowerPoint presentation, so that you will circulate it, so that you just please repeat at least once with the data set that with my data set, for doing this cluster analysis. And then once you do it, you'll become confident of applying cluster analysis in your studies. So in case you have any question, I'll be happy, or rather I'll try to answer.
Okay, okay. Thank you so much, sir. So I would like to request to participants, if anyone have any query, any doubts regarding the cluster analysis and the other parts of the SPSS, so no doubt you can ask directly to Professor Dibyojyoti Bhattacharjee sir, and you can ask the question also the other parts of the SPSS, to related the other parts of the SPSS, because Professor Dibyojyoti Bhattacharjee sir is a very prestigious scholars and learner on the field of the data analysis, and as we all know that sir is a belong from the statistics department. So I hope that sir will be try to give the answers of the all your queries and doubts. So now session is open. So you can ask the question to Professor Dibyojyoti sir. Thank you.
Hello.
Yes, yes, Himanshu ji.
Yes, sir. Am I audible?
Yeah, please go ahead.
Good afternoon, sir. This is Himanshu. Sir, you put names in label cases by during analysis.
Yes.
So why you put that the name option in label cases by, sir? What is the difference between label cases by and other variables in SPSS?
Okay, hello sir. Uh,
Yeah, actually, this is name is used in order to identify the individual after they are clustered, because you need to identify your subjects, which subject is going to which cluster. So for that, I have taken name. If you don't want to use name, fine, you can use some serial number, or say you can use their something which is unique, like serial number might be unique, or say. But if you take something big, like say mobile number, or you take the pen number as the labeling variable, then it will be difficult to identify who is the individual going to which cluster.
So if we are not going to analyze any variables, then we put that variable in label cases by.
Not necessarily. Some variable which is used for identification. For example, suppose you have states, Indian states, and data related to Indian states on different socio-economic parameters. The purpose of your study is to group the Indian states into some means cluster the Indian states into some non-overlapping subgroups. So for that purpose, as labels, you need to take the name of the states. What else you can take? Because if you take their per capita income as levels, then you cannot consider it for analysis, and then it will give you some per capita income values. With that, you will not be able to understand which state, because once again you have to come back to your data set.
Okay, sir. Okay, thank you, sir.
Thank you.
Okay, thank you, sir. And many participants have joined this session from the in the background. So you can ask the question in the Hindi, and we will be try to translate your question, and then sir will be addressed. Thank you. Next question, anyone?
Yeah, I think there is a question in the chat box. Sir, what statistics to be used for studying the predicting role of one independent variable on two dependent variables? One independent variables on two dependent variables. Uh, you have to do it separately. You have to do simple linear regression, but separately. One independent, one dependent, then the same independent with the other dependent variable. So that way you can do.
question. Next question.
Sir,
Yeah.
hello.
Mohammed.
Hello.
Mohammed. Go ahead.
Sir, is it necessary for to every study have cluster analysis or no?
What type of study you want to do?
In every type of study, sir, like impact of one variable on another variable, is it necessary to do cluster analysis in whole
No.
studies?
Cluster analysis, you understand the objective. Objective is that you have a large number of subjects, large number of people, say, and you want to group them. You want to don't want to deal with so many individuals, but you want to group them. That let me find out whether some people are similar in some aspect. I give you an example of the customer segmentation.
Yes,
That means suppose there is a in your town, say there is a multi. You are from India.
So, sorry, sir.
You from India.
No, I'm not from India, sir. I'm studying in Kerala, Mahatma Gandhi University, Kerala. I'm not from India.
Okay. But Mahatma Gandhi is and Kerala is in India only. You are
Yes.
okay, fine. So you'll find in this it's in Kottayam. It's in
Yes. It is in
So
Kottayam.
Kottayam is, then you must be finding that there are some multi-branded retail shop, isn't it? Like Smart Bazaar, etc. And now
Yes.
you'll find that these Smart Bazaar people are purchasing different types of things. Some people are going purchasing food articles. Some people are purchasing vegetables also. Some people are purchasing dresses. Some people are purchasing some luxury items, etc. Now, suppose the company store manager, he wants to segregate his customers. That these customers, they are interested in buying this product. These customers, they are interested in buying such and such product. So what he does, he will apply cluster analysis. Cluster analysis will divide the entire group of customers into some subgroups. Like these are the people who are more interested purchasing, say, health drink, health products. These are the people who are purchasing fashion items. These are the individuals who are purchasing grocery items and other types of household articles. So then what happens, it is easier for the store manager to approach. So that is the purpose of cluster analysis, roughly.
Oh.
If you
Okay,
have
sir. Thank you, sir.
something of that in your work, then you use cluster analysis. Otherwise,
Okay, sir.
not necessary.
Okay, sir. Thank you, sir. Thank you.
Thank you.
Anyone? Anyone have any questions? You can also write your question in the chat.
You can write in your chat box if you have some questions.
Yes. Okay. I think yes. Anyone? Someone has sent me message in the WhatsApp. Yes, you can ask directly to sir or write the chat box. Otherwise, we will be in the session. So, thank you so much, sir. First of all, you have accepted our invitation, and really you have delivered a very wonderful lecture, which is very necessary for the research scholar and also relevant for the research. So, and I'm also thanks to the Professor Bhattacharjee, madam, who has suggested your name, sir. Dibyojyoti Bhattacharjee, madam, because firstly she has suggested your
Yes.
name, and so thank you. Now I would like to invite to Himanshu Sekharji for the formal vote of thanks. So, Himanshu Sekharji, can you listen us?
Yes, I am here.
Okay, over to you, sir.
Thank you for giving me this opportunity. Thank you so much, Professor Dibyojyoti Bhattacharjee, sir. It was really an insightful session for all of us. You gave a very best example with your all data set. It will really help us for us. So thank you so much once again, sir, and thank you all participants.
Okay, okay. Thank you, sir. Thank
Okay.
you.
Thank you. Because I am sending the this one PowerPoint presentation. I have already sent you in WhatsApp, and data set I am sending within few moments.
Okay, okay.
You can circulate amongst the participants, so in case they want to practice it, so they can do it.
Okay,
Thank
sir.
you.
Okay. Sure, sir. Sure, sir.
Thank
Thank you,
you
sir.
once again
Thank
for
you
the
so much, sir.
opportunity.
Thank you, sir. Thank you.
Thank you.
Oh. And now, Dr. Subhangi Amble will be send the attendance sheet to the chat box. So I hope that you all will be fill the attendance sheet. So Subhangi madam, are you here? Okay, okay, okay.
Yes, sir.
हाँ सब लोगों को मिल गया अटेंडेंस शीट चैट बॉक्स में नहीं चैट बॉक्स में चेक करिए अनुराग यादव जी उन्होंने सेंड किया है अभी ओके ओके सब लोग फिल कर दीजिए उसको